There's a difference between what gets announced and what gets left between the lines. Every time something unusual enters our solar system, the same process happens.
A NASA-funded telescope, the Atlas Survey Telescope in Chile, first reported observations of the comet on July 1st, 2025 to the Minor Planet Center. And NASA has been tracking and studying Comet 3I Atlas ever since.
Press release, simplified explanation, short media cycle, and then silence. The public is left with just enough information to stop asking questions. And that's exactly how 3I Atlas was introduced to the world.
But this one came from outside the solar system, which makes it fascinating, exciting, and scientifically very important. This is only the third interstellar object like this that humanity has ever found.
3I Atlas has been in interstellar space for a very long time. There is circumstantial evidence, given how fast it has come in to our solar system.
A harmless interstellar visitor, a rare but natural object, a scientific opportunity. But when you look deeper, past the polished headlines and technical jargon, a different story begins to emerge. One filled with anomalies, unanswered questions, and details that never received proper attention. Before we break it all down, if you enjoy uncovering what mainstream reporting skips over, hit the like button and subscribe, because this one goes where official briefings stop. Now let's talk about what NASA should have told you, but didn't. When 3I Atlas was first detected, most attention went to its origin. Scientists confirmed it came from outside our solar system, making it only the third confirmed interstellar object after Oumuamua and Borisov.
Hey, welcome back. Tonight on the future of everything, interstellar. How amazing is it that we humans have a word for something that literally flies between stars? And so far, we've only known about 2 interstellar visitors in our recorded history. That is, until now, because astronomers have just detected another something out there blazing into our solar system at like 152,000 miles an hour. And unlike Earth and the rest of the planets that are locked into orbit, this thing is not going to be here for very long.
That alone should have been massive news. But instead of treating it like a breakthrough moment, the focus quickly shifted to safe language. It's a comet. It's natural. It poses no threat. And then they moved on. But here's what didn't get enough attention. 3I Atlas is not behaving like a normal comet. Not even close. Most comets follow predictable patterns. They brighten as they approach the sun, develop tails in expected directions, and their rotation and composition stay within known ranges. 3I Atlas doesn't follow that script. Its light curve, the way its brightness changes over time, doesn't behave smoothly. Instead, it shows irregular fluctuations, almost like something is interrupting its natural outgassing. Not random spikes, not solar flares, but structured deviations that don't align with anything commonly observed in standard comet behavior.
This comet's really cool because it does have that tail from the sun's radiation blasting it, but it also has a forward-facing tail.
If the sun is here and the comet is here, the sun sends the solar wind to the comet, the tail goes behind the comet. Guess what? This comet is at the reverse side.
But is it nature or something else? We're going to find out soon.
NASA acknowledges the data, but avoids emphasizing the pattern. Let's talk structure. One of the most overlooked aspects of 3I Atlas is its surface reflectivity. Comets are typically dark. Their surfaces are covered in ancient dust, carbon compounds, and space-weathered material that absorbs light rather than reflecting it. But certain regions of 3I Atlas reflect sunlight far more efficiently than expected. Not like ice, not like dusty rock, but closer to materials with smoother, denser surface compositions. When amateur astronomers pointed this out using publicly available data, the response from official sources was simple. Instruments sometimes exaggerate reflectivity. But here's the problem: multiple independent observations from different telescopes, different ranges, and different light spectrums all showed the same unusual reflectivity zones. different tools, same anomaly, and that tends to rule out equipment errors. Then there's its rotation. Most comets spin in relatively chaotic ways, tumbling, wobbling, or rotating with irregular periods caused by uneven outgassing. 3I Atlas shows something different. Its rotational period is surprisingly consistent for an object that should be dynamically unstable. And not only that, certain rotational patterns seem to repeat with mathematical regularity. Not perfect, not mechanical, but cleaner than random. NASA reported its rotation data, but they didn't emphasize how unusual that stability actually is. Because once you do, people start asking uncomfortable questions. Another detail buried in technical papers is its outgassing behavior. Comets release gas and dust unevenly as sunlight heats their surface. This usually creates chaotic jets, unpredictable bursts, and shifting tails. 3I Atlas does release material, but its emission pattern has shown periods of rhythmic pulsing. Not steady streams, not violent eruptions, but intervals, like something regulating pressure instead of just melting randomly. This isn't common in natural cometary physics. And when some researchers suggested that its internal structure might be more complex than expected, that's when the wording became cautious. They didn't dismiss it. They just stopped talking about that part. Let's talk trajectory. 3I Atlas didn't just wander into our solar system like a lost tourist. Its incoming path was unusually clean. Most interstellar objects show evidence of chaotic gravitational scattering, their paths distorted by passing stars, debris fields, or galactic interactions. 3I Atlas came in smoother, straighter, not perfectly. Nothing in space ever is, but cleaner than expected for an object that supposedly drifted through the galaxy for millions of years. NASA described this as fortunate detection geometry. But the wording matters, because fortunate implies chance. And we're talking about a universe where chance usually leaves scars on trajectories. Now let's touch the subject everyone avoids: composition. Spectral analysis of 3I Atlas revealed chemical ratios that don't perfectly match objects from our solar system. And yes, that's expected for interstellar visitors. But some of the ratios fall outside known formation models for both local and distant stellar systems. Not by a huge margin, but enough to make theorists uncomfortable. The type of uncomfortable that leads to longer internal discussions and shorter public comments. You'll find these words in official material: unusual, anomalous, requires further study. What you won't find are potential reasons why, because explaining the implications leads into areas nobody wants to speculate about too publicly. Now let's talk about what NASA absolutely avoids highlighting: observation prioritization. When 3I Atlas was confirmed, several telescopes were suddenly retasked. Observation schedules changed, time slots shifted, tracking windows extended. None of this was loudly announced. But institutions don't rearrange observation priorities for something they consider just another comet. They do it when something deserves attention, and 3I Atlas clearly does. But instead of telling the public, we're focusing on this because it's highly unusual, they keep the narrative calm, simple, and non-threatening. Because calm narratives prevent panic and controlled curiosity. Then there's timing. 3I Atlas arrives at a moment when humanity's detection capabilities have finally reached sensitivity levels high enough to notice these fast, dim interstellar objects. So the real question becomes, is 3I Atlas rare? Or is it just one of the first we're finally capable of seeing? Because if it's the second option, then it changes everything. It means interstellar objects may pass through our solar system more often than we think. Most go undetected. Some get noticed too late. And a few, like 3I Atlas, arrive when we finally have the tools to watch them properly. And when you start thinking that way, it stops being just a comet. It becomes data, a message in motion, a sample of the galactic environment we barely understand. One physicist described it privately like this: when someone walks past your house, you don't care. But if they walk past your house and leave something behind, then you start paying attention. 3I Atlas is leaving things behind: ionized trails, gas signatures, material we've never analyzed before in this context. And yet, most mainstream coverage makes it feel like a short event you'll forget in a week. That disconnect exists for a reason. Because if the public understood how much is still unknown, they wouldn't stop asking questions. Does this mean NASA is lying? Not necessarily, but they are simplifying, softening, controlling narrative weight. Because institutions don't run on full disclosure. They run on maintaining stability. And certainty is more comfortable than ambiguity, even when ambiguity is closer to the truth. So what should NASA have told you about 3I Atlas? They should have said, "We don't fully understand this object." They should have said, "Its behavior doesn't cleanly fit our current models." They should have said, "Its structure, rotation, and emission patterns raise questions we don't yet have answers to." But they didn't. They turned it into just another space rock story. Because another space rock is easier to digest than this object challenges our assumptions about how interstellar bodies behave. And institutions don't disrupt assumptions unless they absolutely have to. So here's where we stand. 3I Atlas is passing through. We're watching. They're analyzing. And the public? Given a simplified summary. Not because the truth is terrifying, but because it's unfinished. And unfinished stories make people uncomfortable, especially when they're written across the sky.